Okay, for today, we're going to go ahead and talk about constructing quadratics. So we're on page 24, 4.4. Okay, I think by now you should be familiar with the standard vertex and intercept form. Remember, your vertex is the point HK, and your x-intercepts are P and Q. Okay, so this today, rather than me giving you an equation, you identifying some of the key features, I'm going to give you some key features, and then you're going to have to tell me what the equation is. So here I have the x-intercepts are 1 and -2, and we've got this point on our parabola 212. And it says, given the information, which form would be the best to use to write this quadratic? Well, since I have my x-intercepts, it's probably easiest to use the intercept form. So remember that's your y equals a times x minus p, x minus q, right? So it says, what variable is unknown? Well, our x-intercepts, that's going to be this p and this q, right? Our 1 and our -2. And then I have a point. Remember, a point is an xy ordered pair. So I could plug in 12 for y, and my x is going to be 2 in both cases. So that means that my unknown variable is a. And that will usually be the case that we don't know a. So plug in the variables you do know and solve for the unknown one. So we know that 12 is our y. We don't know a. I'm plugging in 2 for my x, minus my first x-intercept of 1, times 2 for my x. And here there's two things you could do. You could do minus and -2, but we know that's the same as plus 2 for our y-intercept of -2, which is probably a little easier. So then I've got 12 equals a. This is 1 times 4. So 12 equals a times 4. So divide both sides by 4. And a equals 3. So that means our equation would be y equals 3 times x minus 1 times x plus 2. And that is it in intercept form. To give you a little practice, do you guys think you can convert this from intercept to standard? Getting back into standard form, remember all we do is multiply and simplify. So y equals 3. I would think about distributing that. So x times x is x squared. X times 2 is 2x, -1 times x is -1x, -1 times 2 is -2. So y equals 3, x squared plus x minus 2, y equals 3x squared plus 3x minus 6. So this is our intercept form, and then this is our standard. And let's just graph it to check. So we would expect, it says our intercepts are at +1 and -2. The point 212 is on our graph. Here, do you think you can identify, also another one too, if it's in standard form, we know our y-intercept is -6. That seems to follow the pattern that we have. Here, just for kicks, what would the vertex be? So remember, there's two ways you can find the vertex, and when you have it in intercept form, so this first one, it's halfway between your two x-intercepts. So your axis of symmetry is 1 plus a -2 divided by 2, which is -1/2, which that seems about right. We're saying, hey, right here is where it's reflected across. So just for kicks, I'm going to plug in -1/2 into my equation. 3 times -1/2 minus 1 times -1/2 plus 2, and then we have -6.75. So we're saying, hey, that's my vertex, my min, and then these should be reflected on that other side. So if the point 212 is there, that's 1, 2.5 away, so 1/2, 1, 2 on the other side. This is what my parabola looks like. And remember, if you ever want to double check that on your calculator, you could do, there's kind of a couple ways you could double check that, right? We could do 3 times x minus 1, x plus 2, And if you want to double check that you've converted it correctly, why not graph that same equation? I am going to just change my window here. If you press the second plus 712, it will reset it back to these. I wanted to double check that it looks like it's a good window, but negative 10 to 10 is probably pretty decent. So if I hit graph, that looks like the parabola I have. It is concave up. Looks like it's got the same min. And notice how that second red graph appears right at the same spot. We know for a fact then that these two equations are equivalent. Okay, this is a follow-up question. Sorry, I probably should have done this as like another one. Similar idea. What if I wanted to have another equation? Let's just say in intercept form. But what if I said the x-intercepts, I didn't word this very well, is 1/2 and 4, and a is 1? What would your equation be then? Well, if we know our x-intercepts, it's just x minus 1/2, and then x plus 4. Okay, next we have, I've given you the vertex, which is 1, 5, and a point to negative 13. So which form do you think is going to be easiest to use? Sure enough, your vertex form. So remember that's your y equals a times x minus h squared plus k. So what variable is unknown? Well, my vertex, this is my x value, my vertex, so 1. This is my y value, my vertex, so 5. And then I've got an ordered pair, so an x and a y. So y is negative 13, x is negative 2. My unknown variable, once again, is a. And that's generally the case. So plug in the variables you do know and solve for the unknown. So negative 13 equals a times negative 2 minus 1 squared plus 5. Negative 13 equals a times negative 3 squared plus 5. Negative 13 equals, negative 3 squared is a positive 9a plus 5. So you get negative 18 equals 9a. So a equals negative 2. So that means your equation in vertex form is y equals negative 2 x minus 1 squared plus 5. So remember this is your vertex form. And then it says, it gives you some practice, let's get into standard form. So in order to convert something to standard, we're going to expand. We're going to multiply and simplify. So remember this is x minus 1 times x minus 1 plus 5. Hopefully by now you know how to multiply this. So if you need to pause for a second, you should get x squared minus 2x plus 1 plus 5. And you distribute your negative 2. And then we combine our like terms of negative 2 and 5. So y equals negative 2x squared plus 4x plus 3 is the equation in standard form. Okay, last but not least, I'm going to give it to you from a graph. So this graph has x-intercepts of 2 and 6. So we could say x equals 2, 6. We also know the vertex is 4, negative 2. And we do have a point as well. This we have the y-intercept, an easy one, so 0, 6. But you could pick any point. The point, 1, 2 doesn't quite line up. It's 1 more like 2.5. But you could use your vertex or your x-intercepts, or even the point over here of 8, 6 would work as well. So let's choose a form to write it in. In reality, I could use x-intercept, I could use vertex, it doesn't matter, pick the one that you like the best. I'm going to go ahead and try it with the intercept. So, my y value, I'm going to use my point. I could use my vertex or my, I think my y-intercept's a little easier. So I'm going to do 6 equals, I don't know what a is, my x is 0, minus 2 for my x-intercept, 0 again for my x, minus 6 for my y-intercept. So 6 equals a, and that's just negative 2 times negative 6, that's 12. So a equals 1/2. So that means you got your equation y equals 1/2, x minus 2, x minus 6. I could also, if you want, just for kicks, if you decide to do it in vertex form, same idea. 6 is my y as my point, my y value, my point. I don't know a. my x is 0, minus my x value, my vertex, or my h is 4 squared minus 2. So 6 equals, in this case, I've got 16a minus 2. So I add 2 and I get 8 equals 16a. So a equals a half. So you get y equals 1/2 x minus 4, squared minus 2. And then converting it to standard form, in all honesty, we could have even written in standard form to begin with, but it's probably a little easier. I take that back. It would be hard because you don't know your a and b value in standard form, so you have to find both of them. But since we have it in our vertex and intercept, we do know how to convert it. So I'm going to take it from the y-intercept, the x-intercept, and multiply. So we get x squared minus 6x minus 2x, that's minus 8x, plus 12. So your equation in standard form is 1/2 x squared minus 4x plus 6. So we now know how to, given some key features or given a graph, write an equation, a quadratic equation.